Hey everybody, thanks for joining. Just one second.
Is being recorded and/or transcribed.
Hey, I'm trying to share out my two Proctor slides. Hey everybody, welcome to the Global 2020 Summer Azure Data Fest. I've seen these slides before. I'm going to go ahead and just ramble through this just real quick. We had over 600 RSVPs. We have about 250 in attendance. Thanks to our speakers and sponsors and staff. Always take a look at the event schedule to see what other sessions you might want to attend. You can download the speaker slides after the session wraps up. Here is our YouTube channel. We're going to upload these recordings. We've got the Summer Global AI ML Fest coming up on July 31st. And in terms of when we're going to do another Data and AI Fest, it'll probably be at some point in the late fall. Got some really good presenters all throughout the day. And then right now I'm going to hand it off to Raheel, Retiwalla, and Elvis D'Souza to talk about best practices for implementing a modern data architecture with Azure. So that wasn't even being shared, but so guys, I'm going to just go ahead and hand it off.
Awesome. Thank you. Tim, just checking you can hear me okay and see my screen.
Yep, I can see your screen. I can hear you nice and clear.
Excellent. So welcome everybody. This is Raheel Retiwalla from Productive Edge. For all of you on the East Coast, thanks for giving us your lunch hour. We promise to make it exciting and informative as we can. So the session today, we're going to focus on best practices. Really, there's so much innovation out there, and I'm assuming a lot of you have probably attended other sessions today, and I'm sure in other conferences. And there's just a lot of innovation that's happening in big data, modern data technologies. The challenge that we see at Productive Edge is how to execute and take advantage of a lot of these technologies, right? And I think you'll agree that when you think about the core areas of the change that modern data platform brings is really in more of the cultural aspect of and the processes that need to be changed in order to take advantage of that technology. And some things haven't changed. From an IT and business relationship standpoint, the need for data hasn't diminished. It has only accelerated. And data is being used more than just for core decision making. It's also used for enhancing your customer experience. It's being used to embedded insights within products and services so that these products and services are creating a competitive advantage for a lot of the organizations. So the need for insights and data and analytics and advanced analytics just continues to grow, and so does the innovation in technology. One of the things that also hasn't really changed is the need from a business standpoint to actually want data now. This idea that I'll put in a request and requirements, wait for 6 months before I'll get something, and by that time my needs and the business needs and the climate and perhaps even the areas of business impact have changed, just isn't working or isn't going to work anymore. This idea of restrictions, what I can and cannot do, also doesn't work. And one of the reasons why that doesn't work today is because, fundamentally the types of technologies that support wide variety of users to participate in the ecosystem has grown. So it's no longer just me knowing absolutely just SQL or MDX. It's Python developer, a .NET developer, a data scientist, a autonomous. We looked at awesome technologies at scale earlier. This autonomous cubes technology, this idea that citizen developers can participate now. So this idea that from an IT perspective that we would put restrictions on isn't going to jive with sort of this digital first mentality. So the reality is that something has to change. And it is this area where where a modern data platform really shines. When you think about just put a traditional BI platform and approaches really next to a modern data platform and modern data approaches and architecture, there are some core fundamental areas that will call out differentiation in the two. And it's not about saying that you shouldn't follow a traditional ETL data warehouse, data mart sort of approach. Or it's not saying that a modern data approach is superior to that. It's about recognizing there are some needs from a business standpoint, and the need for insights is accelerating. And from an IT perspective, we need to be able to adapt to that. And how do we do that? So when you think about the workflow considerations that today exist and have always existed, but they just have become more and more prevalent, things like data movement, this idea that I can duplicate data again and again, to satisfy needs of certain users. Well, that just it doesn't work today. This idea of storage and compute was quite different in the traditional BI world, where we had engines that had storage and compute together. Now today in the modern cloud, modern data world, we have storage in a data lake concept, but various types of compute that various types of expertise, people with different types of expertise can apply and use. So how do we think about taking advantage of that concept and bringing it into our organizations? So we're going to think about data modeling. We just heard about autonomous cubes technology that in many ways is actually autonomously modeling data on the fly. What does that mean? Do I have to now build structured, full-fledged structured data marts? Or can we take advantage of such technology? As an example, data governance, we think about data governance and the role it plays now, and how a bigger and important role it plays now to enable the trustworthiness in the data so that people are able to actually say, what, I'm not going to spend arguing where the data came from, what it is, or whether I trust this, whether it's clean. I expect it to be, and it is, and I'm going to be able to use that. So if you think, and the workflows are evolving, and the need for applying modern data concepts exists across the board. The thing that actually is quite interesting and what we've seen is the adoption strategy. Well, it's not that you can start from scratch all the time. And you've got a traditional BI environment, you've got a data warehouse, you have an advanced analytics sandbox potentially somebody has started. How does all that come together in a meaningful way that that starts to deliver real value back to the business? And the heart of it is really the people, process, and technology part, right? I mean, from a people perspective, the skills needed and perhaps the types of people that are now involved are different than they used to be. From a process perspective of how we think about IT actually enabling business users and even IT users themselves versus focusing on doing a lot more of it. And from a technology standpoint, we've just talked about a variety of different innovation that's taking place. So fundamentally, a few things are happening, and we want to talk about that in this particular presentation. One is, you shift from a traditional BI platform mentality, approach, technology towards a modern data platform. The other thing we've seen people really focusing on doing is say, how can I bring the two together? A hybrid approach. How do we kind of think about my existing environment and adding on capabilities, but making sure they work well together? And finally, this idea of how can I take, rather than adopting brand new, how can I take concepts from modern data architecture and modern data approach and platform and processes and apply them into my existing environment? And these are all valid choices, valid options, and it really depends on you as an organization, what kind of maturity you have in terms of how data is used and monetized and leveraged across the organization, and a wide variety of factors go into that. But fundamentally, those are options. The challenge, some of the challenges, core challenges do exist. One, for example, is how do I transition to a modern data architecture? Right? How do I enable people versus focus on me providing everything? How do I upskill? How do I provide data services without enough understanding of how the data will be used? Because not all the time we know exactly how people want to use the data, and how will it be used to generate what kind of insights? How can it be shared across the organization? this idea of refocusing on data governance to focus more on not making the source of truth, but making more from a data governance perspective, making the data trustworthy. How do we, make sure IT doesn't become a bottleneck or is not perceived to be a bottleneck in the sense that, this idea of me spinning up a data set very quickly so that I can do things with it. How is IT, how am I enabled to do that? This idea of service creation, automated testing, the data is tested, data quality, and self-service reporting. There's also a lot of technologies. We see constant, innovation being coming. So the other question most people have is, well, what do I use for what, and why, and what is it going to look like 18 months down the road when things are going to look different? So the challenges are really quite varied, and I think from a perspective of this particular session, we wanted to just frame the conversation, in a core 3 areas. The first is just take a look at what does having a modern data platform architecture mean. Then talk about what are those data platform practices, specifically taking Azure into consideration, that we should follow in order to ensure that this approach is enabling and providing, some of the, and addressing some of the challenges that I talked about. The third is this idea of data ops and embracing that to make the ability for the organization to create new data sets relatively fast and enable the creation of insights, in a very short time. And then finally, this idea of data governance, making sure that you have the right amount of governance across your workflow components of the data framework. And making sure that the organization is able to actually do what they need to do without feeling restricted. With obviously the governance needed to support regulations and various things out there. So with that, I'll have Elvis start off, with the modern data platform architecture. Elvis?
Hi, can you see my screen?
Yep, we see the image, Elvis, of the mountain.
1 second, sorry. Seems like Teams is not playing well with me. How about now?
Yep.
Awesome. All right. So thank you for that, Raheel. So I'm going to walk through what we've kind of put together to help you understand the modern data platform framework and how to make some architecture choices in terms of what you decide for your framework. And as we saw, there's a lot of things that more modern data platforms they're striving to deliver, right? Raheel walked through a bunch of them, but there's also just as many services and architecture choices you can use within Azure to help you deliver that. And it's hard to say whether there's actually a silver bullet for architecture practices that you can follow for clients. Things are going to depend on your type of scale, your type of need, your type of budget. But the framework allows you to abstract some of those layers of the platform so that you understand what you need to get out of the system before you start to pick your components, whether those are infrastructure as a service components, platform as a service components, software as a service resources, etc. So the framework's not meant to just, it's here to help you simplify and guide you to make those choices and make sure that it's comprehensive in terms of delivering the types of aspects that Raheel talked about, right? It doesn't mean to say that there's not some complexity underneath the systems and the types of services that you choose. It's just trying to help us understand how we can cover our bases to make sure we have a robust data platform. So let's start off on the far left side. So from a data sources perspective, you want to take in a wide variety of data sources, right? You can think about IoT services that are, high volume, high velocity, semi-structured, typically sometimes even structured. You can also look at ingesting sources from SQL databases, NoSQL databases, REST endpoints, file shares, and just unstructured information such as images or audio files, etc. Your platform should be able to take on all of these types of sources, regardless of what their volume and velocity is. That second layer that you see, the ingest, is essentially understanding how you decouple the mechanisms for ingesting the different types of information from these different data sources. and pushing them in through to your platform, right? And so there's a variety of services that you can choose from: pub sub streaming services, your typical ETL services, apps, third-party integration tools as well. And then on the storage layer, you want some central storage mechanism, and we'll talk about data lakes as the primary source of storage to act as your hub to proliferate, access to all sorts of data sources and all sorts of data teams, right? You may have, streaming sources. You may have use cases that deal with trend and historical analysis that you want to cover, and data lakes are going to be your primary route of doing it. There's some storage services that encapsulate not only just pure storage, but they also are compute. And you can see that kind of envisioned in this slide, where you have some SQL, NoSQL databases that can do a certain amount of SQL querying on top of it. You have big data storage like HD Insight. You'll have data warehouse like Synapse that allows you to layer compute over your storage layer. That doesn't mean that these don't have their own internal data stores. There's just opportunities for virtualization in the platform. And when we talk about these architecture choices, they're architecture choices that you make in order to make sure that you can follow practices around, code development and enterprise standards. The analysis layer is primarily compute. So any mixed compute services or compute soul services that you want to use to layer over the data lake and produce some sort of output calculations. This could be dimensional models, semantic layers, etc. And then finally, you have some sort of visualization layer, right? You have some output that's receiving this information or that can connect to the information that's stored in the data lake. What's also extremely important, as you can see in the modern data platform, is not only just these layers within the architecture, but you have to envelop this in good practices around orchestration, DevOps, MLOps. We'll get into that a little more, and then data governance, as Raheel just talked about. Now, there's a host of services that you can choose within Azure, and these slides will be made available to you so that you can kind of take a look at these and think about some of the architecture choices you want to use. I'm not going to go through all of these. It'd probably take me a whole day because they're just so vast and varied. But what's important to really realize is that data virtualization layer, where Synapse can look at queries can look at data directly on Azure Data Lake through things like external tables and virtualize those sets of information. Databricks can do a similar thing. HD Insight does it with, Hadoop clusters do it with Hive, right? It's important to understand that virtualization technologies are ever advancing, as you may have seen in some of the demos here through DataFest. So let's look at an actual architecture. The often paradigm we see is the Lambda architecture. And in a modern data platform, this is primarily the most common one we've seen. There is another architecture pattern out there. It's called the Kappa architecture. The reason I picked the Lambda architecture is because it handles two real different layers of data ingest. So that's a streaming layer, so for more real-time needs, and you have more batch-oriented triggered layers that are considered to be like the cold path or batch layer. Kappa architectures rely solely on a streaming mechanism, right? So you use something like Kafka as kind of your unified your unified log, and use that to propagate the information down to your downstream services. Lambda architecture is a little more complex in the sense that you have to integrate both the speed layer with that hot path and the cold path together at some point within your architecture. So let's start to understand just the hot path core elements and typical use cases, right? So for the hot path core elements, we're talking about things like IoT devices. We're talking about sensor information, log information that's coming at a high volume, high velocity, typically semi-structured or unstructured information, semi-structured or structured information. You'll post that as topics, really event hubs to event hubs, and multiple consumers can pull that information from event hubs. Event hubs is structured as, you can think of it as a log, and so you can replay messages as they're streamed through to other services by building consumers for them. In a typical Lambda architecture on Azure, you'll want to take those streams and process them to something like stream analytics. So that real-time layer can be made available to your downstream visualization sources. But stream analytics can help you ingest that information and apply some sort of parsing and window logic or apply some aggregate logic over a window of information for a particular stream. On the coal path core elements, this is more of that traditional batch-oriented focus. You'll want to use things like Data Factory to primarily orchestrate these. Data Factory is fantastic for moving information, even from on-premise stores to the cloud, or even from within the cloud as well. So from a Data Factory perspective, this is geared primarily to batch ELT orchestration. And it has a lot of integration with other Azure services that you can use. One of the ones that I point out here is Azure Functions. So where Data Factory use cases may not completely, or where some use cases may not be completely covered by Data Factory, it still allows you to integrate with other Azure services to handle pulling that information into a data lake. Now let's talk about the data lake, probably the biggest focus of a modern data platform, where all information, as you can see, is starting to be centralized. One thing to note here, you'll see that there's a little blue arrow coming down from Event Hubs into Data Lake Y. The reason is, as a best practice, try to store as much information and from all sources into your data lake. The reason behind this is you may not be able to think about the analytical use cases or foresee some analytical use cases at a given moment. And so storing that information for posterity, for other advanced analytic use cases that were unforeseen, is extremely important in these types of platforms. So from the data lake, you now have kind of a central hub to democratize information to multiple compute services, right? Let's talk about Synapse for a second. So Synapse is a MPP data store. And there's new features now in terms of what you can do with your typical traditional data warehouse that leverage things that are similar to Databricks. And in that, I mean, there's Spark pools that you can attribute to Synapse that can do some more advanced ETL transformations or machine learning model creation through, Python or Scala. But typically, you use Synapse for that semantic model, so what you would look to as your traditional data warehousing methodologies, right? Creating a dimensional model using a Kimball methodology or NMON methodology, if that sparks your interest. And then finally, from the advanced analytics elements, you have Databricks, you have additional integration options for doing ETL with more complex structures. Those Synapse are starting to blur that. And Databricks especially excels in things like development of AI and ML models. The ops part of that, so testing, training, deploying those models, tracking your experience, is something that can be done through Databricks ML Flow, but I find that machine learning services really has a nicer UI and a better user experience behind tracking all that. Now you can see how the ingest store layers form kind of the core components to going over to your visualization layer. So you can output that to app services, mobile apps, bot services, and even Power BI Premium for dashboards. A couple of more layers, right? We talked about orchestration and DevOps. So for orchestration, you can, again, use things like Azure Data Factory for tying together workflows and pipelines. Azure automation really comes in handy when you want to do simplistic scripts that can pause, start resources. So keep that in your toolbelt as well in terms of thinking about what you need to use it for in the architecture. Azure DevOps is, project tracking and how it relates to CI/CD practices. We'll cover that in detail. And data governance, so you look to Azure Data Catalog for discovering and profiling information, Azure Active Directory, IAM, RBAC policies, ACLs, we'll get into a lot of that, and some native aspects of security services that are within the systems themselves. And then make sure you have things like Key Vault to centralize, secrets, stores, and certificates from one place, and then Azure Monitor for auditing, logging, compliance. So there's a lot to unpack there, as you can see. And understanding what platform practices you can apply to these is vast and varied, especially when you think about the different subsystems themselves have their own practices. So what we try to do here is try to make sure that you keep these primary main practices that we've learned from our experiences in your mind as you start to develop your implementation. So let's just start with one. You just need to make sure you have a strong workflow and orchestration pattern. What this means really is making sure that you understand how you do things like restart your pipelines. How do you pick up something when you've experienced schema drift, or you experience data drift, or if a data validation mechanism fires off and fails the pipeline? How do you deal with all these types of new occurrences? You know, when you talk about the new data sources that need to be onboarded, understanding across your team what types of workflow and orchestration patterns you have available to you, and making that clear up front really streamlines the process. And you can do a part of that through understanding how your data ops patterns work and how your data governance process and patterns work. Understand what your business initiatives are, right? So is there a need for self-service where things like semantic models are going to play a bigger role, versus are you looking for more advanced analytic initiatives, something more complex in terms of ML modeling, or prediction, recommendation engines, things like that? Where do those fit and what types of services really play into that is important. I want to look at things like SQL Server Database, Synapse, Azure analysis services for those more semantic model representations, and Spark and Databricks for those advanced analytic initiatives. This is so core, leveraging functional principles. We just see a lot of this not being done. Storage is cheap on Azure. Use it to your advantage, right? Especially in terms of immutability. What does that mean? That means when you write data out, you write it once, and then any transformation that occurs on that data is another write of that information, right? So you're versioning that information, and you can track the lineage behind where not only information came from, but how it was transformed from point to point. Item potency, understanding how you apply tests to make sure that you're not seeing any side effects of your data flow pipeline, right? Including these tests not just at the end of one pipeline, but as you work through your pipeline, injecting it so you're making sure that you alleviate stress from developers about what might happen in production or in your user acceptance test environments. Reproducibility, this is a big one as well, which is, let's say you have information that needs to now go through a different set of calculations, or you need to replay information, right? Replay that same set of data sources, but through a new compute pipeline. Understanding how that ties into your workflow is extremely important, because somebody may want to call for a new measure or a new metric in your data warehouse, or they want an alteration to a portion of what's being subsisted within Databricks in the Databricks database. And how to replay that from data lake is extremely important. Understand what your patterns are like, right? Do you need an offline pattern? Do you need an online pattern? Or do you need a nearline pattern? All that simply means is, how is data being accessed more often? Do you look at a lot of just offline information that's being batched or served through the lake, right? That there's not a massive requirement to, that maybe need some distributed access to, but is primarily offline? Or do you need something that's more online, more OLTP style? Look to databases for that, right? Or look at something that's more nearline, so streaming mechanisms, as we saw, like Stream Analytics, to serve that. Costs. Don't idle on tracking costs. Make sure you use cost management and use the EA Enterprise APIs to download costs for your builds. But more importantly, monitor, right? So make sure you're monitoring and integrating what you see costs on a daily basis and apply that to something actionable. You can set up action rules within alerts that allow you to tie them to services like Logic App. So if you see a dev process that's running longer than it should, you should be able to cancel out of that automatically after a predefined threshold, right? Implement governance and data ops early. We'll get into this a lot more in a minute, but it's really important to do this sooner rather than later. Waiting at the end causes you to re-engineer portions of your pipeline to fit governance and data ops, and you're just going to, turn into a world of hurt and painful kind of political football if you try to wait too late for this. Transparency. So number 7 is capturing counters and metrics. This is so important. I can't stress this more. But regardless of what pipeline is running, what inputs it's taking, what outputs it's taking in, capture that information in a way that can be transparent to your team. Looking at things like, if you're sitting or if you're standing really in a stand-up, and being able to look at a dashboard that tells you exactly what the runtimes for a pipeline are looking at over the past couple of days, or whether the outputs are not meeting the validation thresholds that you put in place over time, really allows you to capture things very quickly and allows you to turn around inefficiencies you see in the system to users in a timely manner. In short, your teams just know how to collaborate. Fundamental principle, but often overlooked. Look at distributed version control like Git. Use Azure DevOps for CI/CD workflows. Use wikis, readmes. Use SharePoint. Try to encapsulate information and documentation around your processes. I found especially like using mermaid diagrams within the wikis is so helpful when you're onboarding somebody new to the system. They can go through a wiki and they understand what the workflow for your data pipeline process looks like. Use these to your advantage and make it transparent to the team. Enable unit test, integration tests, and end-to-end testing. This is really more about automation more than anything else, and we'll stress this in the DevOps and data ops section. But essentially, automating a lot of these tests through pinch points of your data pipeline is going to streamline how fast you can deliver something to somebody without fear of screwing something up in production. A lot of times you'll see more integration or end-to-end tests and very few unit tests, where you want a lot of unit tests, spend more time on unit testing and creating more unit test suites and cases versus integration tests and end tests, which sometimes get a little more complex and hard to do, but we'll take a look at what you can use to make those effective. And lastly, do postmortems after your sprint is done and you've released something. Do a postmortem that allows you to look back at that dashboard that you've created and say where you faltered and start to remediate some of those issues in a more holistic process by looking back at these best practices that you might have missed. So let's look at data lake best practices. These are very similar to across platforms, especially around best practices for even other cloud services. But from a data lake perspective, you want different zones to categorize your information. You want a raw zone to capture more unrefined data, so try to keep it native, as close to native as the source system. That's a preference. Though there are some exceptions to that case where there can be outputs from Avro for example, if you use like Event Hub Capture, you might output an Avro, right? But essentially, it should be as native as possible to the source system that you're extracting from. Stage is a place for you to do some minimal standard quality practices, right? Like make sure that all your date time stamps and formats are in the same structure, because examples like that allow you to open up access to other teams so that everybody knows they're talking about the same type of language or same type of formats to access some information that they want to use for their either advanced analytic use case or for something new to their data warehouse platform. From a final zone standpoint is a curated zone. The curated zone really is more about aggregated data sets, things that have been thoroughly vetted, tested, certified. These are free for distribution. Doesn't mean that there's no security around them. It just means that they're a much more refined set of data that people can take to the bank. And then finally, in your data lake, create a sandbox zone, right? This is primarily just an ephemeral area where data scientists, advanced analytic use cases can take information from either the curated stage or raw zones and do something with them to test out their theories, right? Or develop and test and train their models. As I stress again, write data sets with an atomic, immutable approach. Partition data in these folders into predictable structures. Typical structures look like a top-level folder of a domain, sublevel folder of a subject area, and then use some sort of time partitioning depending on your strategy. Whether it's streaming, you may want it down to the minute, hour, or for more batch scenarios, you may want to think about just the day level. Leave room for an error folder. So for any outputs that are corrupt, make sure that you have a space to output those to. And make sure you start applying those governance practices, right? Classify and secure data as soon as raw stores are being generated. So let's look at data ops and some of the best practices around that. Data ops is critical in terms of if you want to be agile and nimble and deliver things extremely quickly. A lot of people ask me the question, what's the difference between DevOps and data ops? And data ops is more of an extension of DevOps. There's implementation practices between the two that certainly overlap, but data ops takes a step forward, especially when applying it to analytical processes for teams. And what does that mean? So we look at things like code verification. That can be simply like, hi.
I think somebody else shared the screen. Can you reshare your screen?
Oh.
Somebody shared it by mistake.
Sorry about that. I don't know if I did that or okay.
Back to your mountain.
Can you see my screen now?
Yep.
Okay, perfect. So there's different cycles of the DevOps process. You go through local code verification. There's continuous development. We'll get into that about applying some local tests. Those tests are integrated into an automation process that then your CI platform can apply and run. Those are then piped into continuous delivery, which is as soon as those tests are verified and those automated tests check out, you can push them through an automated way to through a release to a end platform. And even then, it doesn't stop, right? Once you're done with a deployment, you still want to rerun tests, especially input-output tests, logic tests, to make sure that you verify what you're actually seeing on production is what you were actually expecting in development. That doesn't mean go crazy, and you notice unit tests will be excluded from this type of stuff because you don't want to burden the server or burden a service. And then finally, deployment verification and monitoring, keeping track of the type of operational metrics about the server state. What's the resource usage? Is it meeting the compliance restrictions? Try to think about automating a lot of these, or at least incorporating them within a dashboard for transparency. So where does data ops really fit in? Data ops really fits in, and I would really strongly recommend you read the data ops manifesto for more detail. But in very simplistic practice, you apply different goals of the data ops practice to reach this green goal, which is you don't want users worrying about what's going to break you don't want your developers worrying about what's going to break the production system, right? And you certainly don't want your hotshot dev, Steve, spending, hours at night to fix something in production. He's great, he's fantastic, he's a rock star, but the idea is now his time is being taken away from actually creating value or innovation. So I want to stress out particular ones that I see a lot of enterprises fail on. One is just applying in data logic tests, right? You can think about the testing pyramid, and you can look at the testing pyramid and as it pertains to test-driven development. But in terms of an example, what you'd want to apply is on your lowest part of the pyramid, apply unit tests, code analysis, naive tests. Naive tests are simple counts, conformity, looking at things like, is a end date less than a begin date? These are like very, very simple tests that you can implement right from the get-go. Then you get over to integration tests. How do you check whether a portion of the pipeline that's maybe ingesting information from from Synapse appears in or is processed through Databricks and then landed into Data Lake, right? For this, you are going to need a few more complicated mechanisms. You may want to use something like Data Pipeline and create dedicated pipeline tests in Data Factory to check those out with a framework that you can leverage, right? PyTests are extremely also good, using Python is kind of the glue to carry out some of these tests. I've also seen PowerShell. People created PowerShell tests to do this as well. And then finally, and last but not least, end-to-end and manual tests, right? You want to do some sort of end-to-end test that ensures that information landing in the raw zone of the data lake looks like what's being expected out of the final aggregated sets that you see in a curated zone, or even through the front end of a semantic model like Azure Analysis Services, or even a Power BI tabular model backend, right? Then you can't get away from manual tests, unfortunately, but as much as possible, automate a lot of these through your CI/CD platform, and DevOps provides a lot of those ways to do that. The last thing I want to mention is that there's really 3 types of tests you want to try to think about, especially when it comes to analytic processes. Business logic tests, right? These are usually non-naive, like, is this sales figure actually making sense? These are based on thresholds that your domain or your business group is talking about. And then input tests and output tests. Okay. Think about a branching and merging strategy. If you're not using Git, start switching. But really, the idea behind a branching and merging strategy really doesn't depend on Git, though Git would be the best practice, but it really is just about making sure your team coordinates on that approach. Whether you're using Git flow, you're using trunk, align an approach and make sure that the team understands it and documents it so that people are onboarded or people need to review it. It's just available for them. And the other thing is just express as many objects of the platform. This enterprise platform, especially when it comes to virtualization, you'll see this difference through code, right? So you can express SQL Server resources through, to Azure blueprints, or what are formerly known like ARM templates, right? Make sure that you can express things through Python notebooks, through YAML, through SQL, through JSON. There's just so many advantages of that to look at code comparisons and PRs and reviews through the pipelining process that you don't want to let go of, that you should bear in mind. When it comes to other tools such as virtualization, this gets really, really ambiguous, because some are just encompassed and closed in that ecosystem, and then you lose the opportunity to do these types of code reviews for enterprise platforms. Automate delivery. So I think this goes without saying, but I mean, CI/CD, the entire point is just to increase the speed of delivery and make sure that information is getting out there in a quality way as fast as possible. So you can see here I put together a very simplistic one on the right side. It's just building a staging database, building a final dimensional model database, and building an SI set of packages. Just some of the types of build tasks that you can create within DevOps. But the idea is to incorporate not only this, but unit tests, code tests, code analysis, lint tests. You can incorporate all of these to have that completely offloaded to the hosted agent that DevOps runs for you, and then return that feedback when it's all done, which completely streamlines the burden from a developer having to run something locally and waiting for it to finish. They can just be notified about it. And then the other thing is just integrate portions of your workflow to come back into DevOps, right? I think one thing a lot of enterprises just don't take advantage of is that when a bug is placed into, let's say, something like service desk, you can create that ticket directly in DevOps. And you can implement that as part of your development lifecycle. Modularization, reuse, parameterized processing. So this is a thing that a lot of people have trouble with. Take the opportunity to understand how you can parameterize and modularize things, whether that means you put something into a Python container and then start to distribute that to other developers, or you use runtime parameters that you can leverage, such as in data flow. As you can see, why create separate data pipeline activities for each individual table, parameterize those, parameterize the amount of records it can take, the type of batch input streams that it can take. So last but not least is data governance practices, and we'll touch on this briefly. There's really three primary kind of categories for governance. We'll look at discovery and classification, and then we'll look at quality and finally security and access. Within discovery, it's helpful to think about this in 3 different buckets. Classification is just trying to understand, where do certain segments of data fit and how should we tag them in terms of PII, PHI, privacy, sensitivity, right? And you can do this to Azure Data Catalog through a large extent. And then there's the actual metadata behind the information. So what does this column actually mean? What's a description behind it that your SMEs might need to put so you can describe it to other people and proliferate and evangelize your data hub and your platform? You can also do this to catalog. Content and documentation we talked about, Azure DevOps, wikis, SharePoint. Consider it as part of your charter for your data governance group. Management and quality really pertains to 4 primary aspects. So data quality really is about profiling, assessing, and testing the input and outputs, which I tried to show you through data ops. You can through this through, you can profile information to a large extent through catalog. A lot of the assessing, testing placements are going to come through native services like Factory or SQL Server data quality services and Python libraries. From a lineage perspective, we talked about the idea of atomicity and immutability. Tracking this is sometimes inherent in third-party tools that you can use, but if you're going to do it through things like Data Factory, you can capture things through that orchestration platform, but there's going to be segments of it that you want to tailor to make sure that you can capture it all the way through the end use case for some advanced analytics portion. And now Power BI even has lineages to understand where you can draw data from. Data lakes and data warehouses we just covered. Master data is the other thing that I would also point out, using something for consolidating business assets. And then last but not least, from data governance perspective, you want to look at security and access. And as a high level, try to understand how you can implement security and access through Azure AD, RBAC, ACLs. Make sure you use native path security where possible, right? Use things like Key Vault to secure stores. Use Azure Sentinel for any advanced security practices that deliver that address things like penetration and things like that. Data policies and compliance, use Azure Monitor. Make sure you keep track of everything through some sort of auditing monitoring tool. It's not just to please the auditors. It will help you streamline your delivery. And finally, last but not least, try to make sure that your data sources are open and accessible through not just something through a semantic layer, but through some RESTful endpoint, right? You can use OData on top of app service, for example. So with that, I'm going to hand it back to Raheel.
Thank you, Elvis, for that. So I hope you got a chance to sort of see, when we think about transitioning from a traditional BI platform and approach to a modern platform, a modern data platform, it isn't about what's better or should I do this or should I not. I think it's really about how to accelerate the value creation from data in a manner that's sustainable and that's scalable. And that's where when you take a step back and you look at all the various technologies that Elvis went through today and what Microsoft has enabled, you see that it's a puzzle and you can put them together in a very meaningful way, as long as some of the data ops practices that Elvis talked about, the data governance practices, data pipeline management process practices. And then we believe that the true promise of self-service and self-enablement and citizen developers using autonomous technologies, fundamentally starts with clean, trustworthy data, and the ability to actually do that is a critical component of that. So with this presentation, we tried to put in as much in a short time that we felt are critical areas that help in that acceleration and that help in that sort of transition to the thinking around modern data principles. And we hope that you enjoyed that. Just a quick note on who we are. We're Productive Edge. We are a digital business consulting and technology solutions company. We're based out of Chicago with offices in Boston, New York, as well as Eastern Europe. Been around for over 12 years. We focus heavily on modern data platform and analytics, intelligent automation, applying a digital workforce, and cloud native solutions. So if you have any questions, we would love to take them. The slides will be shared. Both Elvis and my contact are there. So we would love to hear from you either today or certainly feel free to email us again. And we want to thank you for your time. Tim.
Thank you very much for a really good presentation. Are there any questions? Anything you want to type into the Q&A box, or do you want to ask a question right now? Get them while they're hot. Get somebody to turn on their webcam. All right, well, I don't think there's any questions at this point, gentlemen. Thank you very much for your time. I'm going to go ahead and hit stop recording.
Our pleasure. Thank you all.
Thank you very much.